Before we can start the topic of geometric sequences today, which is a pattern that's multiplying, we have to first practice a little bit with percent. When you hear 15%, we have to convert percent into a decimal because on a calculator there's no 15% button. So what we do is if it's 15%, we do 15% divided by 100%, and that gives us 0.15. So if we ever want to calculate 15% of something, we multiply by 0.15. If it's 2%, we do 2 divided by 100, which is 0.02. So to calculate 2% of a price, we would multiply by 0.02. How much would a $100 calculator cost if the price increased by 15%? Now this is a little bit of a trick question. The price is going to increase by 15%. So if we multiplied by 15% or multiplied by 0.15, that would only tell us how much money we need to add on. It tells us how much it increased by, but it wouldn't tell us the actual final cost. So what you can think of is when a price increases, anytime a price increases, you have to think of that you keep 100% of how much you started with, and then we're gaining an extra 15%. So our total percent is 115%, and if we divide by 100, we get 1.15 as a multiplier. So in a calculator, I would take the $100 calculator, I would do 100 times 1.15, and I would get $115 as my total cost. Let's do one more example. How much would a $100 calculator cost if the price decreased by 2%? So if something decreases, likewise, I start at 100%, but now I'm decreasing by 2%, or I'm going down by 2%, which leaves me with 98%. So in my calculator, I'm doing 98% divided by 100%, and that is 0.98. A way to think of it is if you decrease by 2%, that means 98% is still remaining. So on my $100 calculator, I have a $100 calculator, and I'm multiplying by 0.98 because 2% decreased, or I'm keeping 98%, 0.98. And my calculator now costs $98. Let's do a couple word problems using this percent multiplier, which is called a geometric sequence. I'm going to have us skip reading the entire story, but just get to the big ideas. So a store is selling something called a pie phone. Ha ha ha, like an iPhone, a pie phone. And the store expects to start by selling 100, and expects to sell an average of 15% more each week. So that 15% more tells me that it's going to be increasing. So although I start with 100 phones, I'm starting with 100 at 0 days have gone by. And I think it's measured in weeks and phones. If it has to increase by 15% more, that means my multiplier is that I'm going to multiply by not just 15, but from 100%, we get 15% more. So we're actually looking at 115%, and then we divide by 100, and our multiplier is 1.15 as a decimal. So in my table, I'm going to be multiplying by 1.15. So if I have 100 phones sold, and I multiply by 1.15, my next number is 115. And that would be after the first week. To get to the second week, I am again multiplying the 1.15, or 115 by 1.15. And to get the next one, I'm also multiplying by 1.15. So on my calculator, I am going to take phone sales and multiply by 1.15. Next time I have 132 phones that I'm going to have sold. And then I take that 132 phones and multiply again by 1.15. And now on the third week, I have sold 152 phones, and so on and so on. Well, let's might as well do the fourth week. 152 times 1.15, and the fourth week would be 175 phones have been sold. So because the pattern here is to multiply, anytime you see a pattern that's multiplying, we call that geometric. It's not arithmetic, it's not linear, and it's not adding. The way that we write this as an equation is this y equals a times b to the x. So this a that you see there, that a is how much you start with, and that b is what is that multiplier rate. Multiplier, or you could call it the rate. So if we were to take this particular story about the phones, to write it as an equation, we'd say y equals, we started with 100 phone sales, and our multiplier rate was to increase by 15%. So we wrote that as 1.15, and then we put x as the exponent. This is called exponential or geometric, and that's your new kind of format of the equation for today. If we wanted to know how many phones they sold in 52 weeks, what we would have to do is take our equation and plug in a 52 as the time for x. So we do 100 times 1.15 to the exponent of 52. Now you can use a smartphone to do that. It's a little tough, or you can use a graphing calculator. You can also use the website desmos.com. And if I do something like that, I get 143,314 phones sold. We'll do a few more examples of this geometric percent multiplier. The new pyroid, Android. Okay, so a pyroid and a rival to the Pi phone is about to be introduced. It is cheaper than the Pi phone, so more are expected to sell. The manufacturer plans to sell 10,000 pre-orders in week 0, so that's my starting amount. And the sales are going to increase by 7%. So if I wanted to write an equation for this, I know that I have y equals, and it should look like a b to the x. A is that starting point. Oops. And b is that multiplier, but we have to change that percent to a decimal. So this one starts with particularly 10,000 pyroid phones sold. And then we just need that multiplier. So if it's supposed to increase by 7%, that means we start at 100%, we increase by 7, so that's 107%. And then to convert that 107% to a decimal, we always divide by 100, and we get a multiplier of 1.07. And our equation needs an x, and we just put the x as an exponent to keep track of how many times we're going to use that multiplier. Part B. What if the expected weekly sales increased to 17%? Now our equation would still have 10,000 phones to start with as a sale, but instead of 7%, it's 17, or 1.17 as a decimal. The last one I'll do with you is number 93. Oh no, thanks to the lower price, 10,000 pyroids were made and sold initially, but after that, weekly sales actually decreased by 3%. So if we start building an equation, y equals, we start with 10,000 pyroid phones still, but now the sales are going to decrease. So we start at 100%, but we have to go down by 3%, which gives us 97%. We keep 97% of the sales, and we divide that by 100 to write it as a decimal, and it is 0.97. And then we just put x as our exponent. So these are called geometric because the multiplier is a percent And the fact is that it's a multiplier, it's not adding. So your goal is to do these last couple for each table below, find the missing pattern, and write the y equals equation. Think about what is the starting point and what is the multiplier.